Hello.
Milk's here.
And MoNaCo behind the camera. We traded spaces today. So Milk's, just so you know, everybody was yelling at me for standing in front of the words when I was doing.
Oh, dig it.
Yeah, so like we'll just be.
You see me?
Now I can. Yeah, we're good.
Right,
So,
good.
welcome, sir. Off.
Gas laws lab, guys. Prelab. See how it's blank? Got some things to go over real quick. Name of the lab, observing gas laws, some of the background that we need to know, right? We're going to follow kinetic molecular theory. We're going to explore Boyle's, Charles, and Guy Lussac's today. That's three different relationships that we put together to make this big bad boy right here. Okay? The laws themselves, pressure, volume, temperature, and pressure, temperature. There's going to be a station for each. And then there is a mini Pogel activity for each of these Avogadros. 1 mole is 24.4 liters, and what do we say? The number of molecules of one gas is equal if they're at the same temperature, pressure, volume. Okay, Avogadro's law. Dalton's law of partial pressures, we haven't talked about this yet in the notes, but if I add up the partial pressures, I can get the total pressures.
Simple enough.
Simple enough. Okay, purpose, we're going to investigate the 5 relationships of gases, and now we're going to go take a tour of the stations.
But not before I correct this one little typo that I made. That's pressure, P versus volume, not R versus volume. So.
Good. All right, first station. Pressure and volume. We have this syringe set up, guys.
Let's see the bottom of that sucker.
This thing right here?
Yeah.
All right, well, here's the 2 pieces that are the most dangerous. I don't want to see this coming off, but in here is where it's going to break the first if it breaks. So we're going to be very careful.
Yeah.
We do need to take this little piece off. Do not lose this.
It's
Muy
the cap.
importante. It's the
Muy
cap.
importante.
So what we're going to do for this lab is we're going to set this thing to a known value.
I think 50 worked last year. What do you remember?
I think it was 35 is what we did, just for stability purposes. I think that'll work fine. But here's the trick. I'm going to set it for just a smidgen above 35. And I'm going to cap it. And then I'm going to give it a little...
Make sure that it's working.
Right, and now look, I started at like 32. That's okay, so there's my starting. So I have to create a little data table.
Yep.
So I needed 3 points, because I have 3 books.
At least. I think we did 4 last year, 3 or 4.
3. Well, we'll do about 3 books. It gets really unstable. Your partner's going to have to help you with this.
This is pressure versus volume.
Yeah, so what we're going to do is number of books versus volume. So here's my starting volume.
0 books
0 books.
is a number.
Right.
Should that go in our data chart?
Yeah, so I guess there's your 4.
Yep.
There's your 4. So 0 books, starting volume, right? And then we're going to put a book on.
Right, and you'll read
A new volume.
book 1, book 2, book 3,
And then we're going to keep going.
You'll
You're going
notice,
to find that this thing gets a little unstable.
which is why we told you to be careful.
Right, I don't want it breaking. And you might need to, here, if you swing around this way. Swing right around. You might see that, I can stabilize
Balance it a little bit without pushing.
Without changing
Yeah,
the pressure, right? And
All
so
right.
we're just going to be able to do this. Later on, you're going to be asked to make a graph
So that's
of
your
that data.
first procedure, Boyle's
procedure.
law, pressure versus volume relationship, verify it using textbooks and syringes.
Yep.
Boom.
Bam.
That's how you
Excellent.
clean up the station.
Yeah, perfect, right?
Nice.
This one is slightly more fun. More fun.
How so, sir?
We have temperature and we have volume, constant pressure. So the pressure inside the room and outside the room,
Same.
same. Temperature,
Not so much.
Okay, so what we're gonna do is,
That's the room,
yep, there you go. So you're gonna record room temperature,
and that's the outside.
and it's out there, and it is
Something.
colder.
It's colder. Not the
Colder.
same as in here.
Colder. And then what we're gonna do is, for volume of the balloon, instead of doing the entire volume, I'm gonna say I can make a relationship about the diameter to call it my volume. So I'm gonna take the diameter of the room balloon.
Right.
What I'm gonna do is I'm gonna hold it.
Measure the volume.
I'm gonna
Or
try it
the-
right around where that mark is,
Yep.
right? And where they meet, I'm gonna hold it
Oink.
and I'm gonna measure.
Right. In what units?
Centimeters.
Right. We hate the English system here. We
Right.
got to use metric.
So I got something off the top, 56.
56 centimeters
Okay.
and at a temperature of indoors.
So there's one set of data points.
The next set's hanging outside waiting for you to do it.
This one's gonna be outside all night. It's gonna be started out the same volume,
Right.
and now, and we used that. We used an instrument to blow these up in the same space.
Right,
And
so
now
we
I'm gonna
know
take-
that they were the same size when we started.
Yep, and now I'm gonna take the diameter of this balloon, which should be. I'm not
Something
saying it.
different.
I'm not saying it.
Something different, don't tell
Be
them.
something different. and I'm gonna
Something
measure that
different.
one.
Geez, it looks kind of the same size to me, but hey, whatever.
Well, it also just went out there, so it needs some time, but.
Yeah. And then the third lab station you're gonna see.
Third lab station, now we're gonna do equal volume. So this volume isn't gonna change any, but temperature and pressure. And here's our pressure gauge. My initial volume at room temperature, which we do know is 0.
Yep.
And then here's the procedure for this. I'm gonna
Initial
pop it on
pressure
the
is
hot
0.
plate that's
You hit
on
And wait.
for no more than 2 minutes.
So you gotta watch the clock careful.
Yeah, somebody's gotta be clocking it and somebody's gotta be watching it.
Dun,
and you're
dun,
gonna see
dun,
this thing
dun,
go up.
dun, dun. Hopefully you'll see it going up.
We will. It's gonna take about a minute before we see any change.
And then all of a sudden it's going to go up. And we're measuring in the pascals or the kilopascals. The red scale is what
Sure.
you're really looking for. I do. It started to move, yeah.
Right.
But I guess what we're looking for is regular old relationships. There it goes. It's moving.
There we go.
It's a moving. So no more than 2 minutes on that one.
Right, because if the pressure gets too high, this thing's gonna pop off.
Can't have
the
it.
gauge is gonna break, and we've got one.
So don't ruin it for everybody.
Don't ruin it for everybody.
And so you'll put that back down on the table when you're done. It won't shatter. It's not going to heat up too much because it's
special glass.
only been there for 2 minutes.
Right, and it's special glass, a little bit more heat resistant than most.
Mm-hmm.
Now, I did not give you a lot of detail about each station. Okay, there isn't any more to do than what we just did. So data table for each, a few different data points, and we're all set.
Right.
Conclusion, and we're done.
Right?
Right, CEI. Claim the relationship between.
Well, you did 3 relationships, so you
Pick
should
one.
say the relationship between pressure and volume of a gas is.
Is it inverse or is it direct?
As I do this, this happens. We want relationship
There you go.
statements.
So as pressure increases, what happens to volume?
You
Right?
decide.
Data evidence. I know my claims are accurate because cite the data you collected.
At station 1, when I stacked up the books, the volume did this. Be
Right.
specific.
There you go. Interpretation. Talk to other groups about the results of their 3 tests. Did you guys match up?
Right.
Was there any deviation?
So this is more of station's activity than actual lab proper.
And then don't forget there are the 2
Pogles.
models. Mm-hmm. You know, they're like mini Pogles even, real quick.
One-pagers.
Just to do Avogadro's law and Dalton's law because those aren't as station friendly and not
Yeah.
as hands-on as that.
Yeah, not
so
as
you guys
easy.
just summed up the whole lab in how many minutes?
7 minutes, 40 seconds.
7 minutes. So
Can-
here's your task. You watch the video as many times as you need to fill out the procedure and the purpose
Right there.
and something about your here,
Procedures.
you want to see the procedures? Up.
Oh,
Sorry.
no, see, there you go. You're supposed to put what we've done into your words stepwise of what you're supposed to do at each spot.
Right. And if I thought that these were difficult data charts to figure out, I'd draw them out for you.
But they're not.
How many points
This
do we really take?
versus a that.
Right. And
So-
you're going to be able to graph that stuff out.
There's your background and purpose.
When you show MoNaCo or I that you're ready to start the lab, you can start the station.
And we'll know you're ready if you have your background and purpose and some procedures that have to be written in your own language.
Right.
Because we didn't list them up there
And
for
I'm
you
going
to
to read
write.
them real quick, make sure they make sense, and then you have a data table already pre-done because you have an idea what you're going to do.
Right.
There you go, and you're off.
Thank you all.
See you.